Hello friends, I am Dr. R. Sabita, working in EC department. I am going to discuss the topic of grand challenges in wireless communications. The contents we are going to follow are the introduction and the grand challenges in wireless communication and the summary. Coming to the introduction part of the challenges, we are going to discuss the developments and the requirements of wireless communications. While talking about the introduction, over the past 2 decades, the mass offering of mobile broadband access to the internet has been dominating the wireless communications and recently became a reality with the introduction of various advanced transmission technologies like multiple antenna transmission and reception, that is MIMO, multi-carrier transmission and channel adaptive transmission, etc. So these technological developments also establish a solid foundation for the future enhancement of mobile broadband services. Coming to the requirements, advanced IoT applications require ultra reliable, low latency and high energy efficient communications for the connected devices. So future human centric devices require accurate localization and multidimensional sensing. So it is necessary to have a full integration of computing, communication and control with the application of artificial intelligence and machine learning for the realization of communication channels. Coming to the grand challenges, there are around 9 grand challenges. Coming to the first grand challenge, it is talking about the security, secrecy and privacy of a wireless communication. So normally wireless communication systems are carrying a growing amount of confidential information. Naturally, the wireless transmissions are broadcasting in nature. However, it makes the transmitted information vulnerable to eavesdropping. So to effectively support various highly secrecy sensitive applications, novel transmission technologies should apply to facilitate or even enhance the information secrecy. Coming to the second grand challenge, which is talking about the resource and spectrum utilizations. The spectrum suitable for wireless communications is becoming increasingly scarce, so which motivate the exploration of new spectrum bands, including millimeter wave and terahertz frequencies. So while enjoying the larger bandwidth, the coverage area over these higher RF bands are generally much smaller due to their higher propagation loss that naturally exist. The most popular mitigation solution is to apply directional beamforming transmission technology. Here the challenge is how to efficiently adjust the beamforming directions with the changing environment, especially in a multi-user scenario. Also, the secondary access of underutilized radio spectrum can accommodate IoT applications with less stringent quality of service requirement. Coming to the third challenge, we are talking about communication infrastructure. Another direction to accommodate the growing demand of wireless service is to improve system resource utilization with novel system structure. So large-scale collaborative cell-free network structure can overcome the limitations of static resource allocation of traditional cellular system. So through joint signal processing enabled by cloud computing, multiple base stations will collaboratively serve multiple users using distributed antenna arrays, achieving high spectrum utilization, efficiency and dynamically responding to the changes in the service demands and propagation requirements. Also, the efficient cross-layer and system integration design, resource management and network optimization, and tractable analytical frameworks for coverage and other performance evaluations are of state-of-the-art importance for the successful implementation of these emerging communication infrastructures. Next challenge is the energy efficiency enhancement. So many IoT applications involve a huge number of resource-limited sensors which are expected to autonomously operate over 10 years. So although transmitting in a specific fashion, these sensor nodes demand transmission schemes with very high energy efficiency. So in certain application scenarios, these sensor nodes may eliminate transmission energy consumption through backscattering transmitted signal from other resources. Next challenge is integration of wireless information and power transfer. So due to the enormous energy consumption expected by the massive number of connected nodes nowadays and also in future, several strategies have been proposed to implement self-sustainable communication systems. So here, the integration of wireless information and power transfer combined together called as WIPT enables proactive energy replenishment of wireless devices and becomes a promising solution to power energy constrained wireless networks. So for future wireless networks, IoT devices will be even more power hungry due to the huge computation needs for intelligent processing. So the integration of wireless information power transfer still has a long road until its successful practical implementations. Next challenge is wireless access technologies. Efficient wireless access techniques are essential to future generation of wireless communication systems to fundamentally meet the stringent requirements, which include a very high spectral efficiency, low latency, massive device connectivity, very high achievable data rate, and ultra reliability devices. Next challenge is dynamic architecture and network functions analysis. So future wireless networks are designed to have a dynamic topology in nature because of network densification. So in which users will have many connections so that user association decision will become a tricky part. So for instance, vehicular systems move quickly and this extreme dynamic environment will change the interference pattern rapidly. So new mathematical models and tools will also be required to provide an accurate analysis and optimization of systems operating in such dynamic topology. So also the use of unmanned aerial vehicles to support dynamic network topologies and emergency communication will play a key role for the successful implementation of these architectures. Next challenge is coding and modulation. So new coding and modulation schemes are crucial in future wireless networks to ensure that gains predicted by theory can be realized in practice. Specifically, advanced channel coding and modulation schemes as well as space, air, ground, underwater integrated networks can help to truly fulfill the massive connectivity. In this case, how to design channel coding, modulation, deduction and decoding with a high data rate, low latency, high reliability and larger bandwidth deserves in-depth investigations in order to ensure its successful implementation. Next challenge is resource and interference management. So in order to support various emerging applications, new resource and interference management schemes are expected in future with wireless networks. So under this perspective, machine learning based technique have attracted a huge interest due to their ability to improve system performance and reduce the computational cost. So a real-time management is another feature which makes the ML-based strategies a promising tool for attending the stringent demands required to new future applications and services. So with this, we have discussed the grand challenges in wireless communications. Thank you.